Well, good morning, everybody. As I've been introduced, my name is Jamie Spranger. I'm the Quality Assurance Manager and a Cytogenetics Tech at CorePath Laboratories. My presentation is titled Cytogenetics, the study of cellular selfies. On our journey today, we will follow this roadmap. This is my presentation outline. We will have an outline, an overview of digital pathology. We will dip our toes in cytogenetics. We will visit the scope of testing, unpack a little bit cell division, kind of tingle with clinical importance of cytogenetics in fish. Go through how images are created, discuss a little bit about image capture. I have some interesting case studies to go through. I have about 7 of them. We'll take a visit with Miss Rosie, and then I'll have some thank yous for the end. So, first you may be asking, who am I and where do I work? Just as my slide stated, I'm a cytogenetic technologist and quality assurance manager at CorePath. CorePath is a full-service reference laboratory. So we provide services in not only, let's see, does this work? It does. In cytogenetics, fish, or fluorescence in situ hybridization, 8-color flow cytometry, anatomic pathology services, and molecular diagnostics. I like to think of CorePath as a one-stop shop for hematological testing. It's really exciting to work in a place where you can work on all sorts of different types of testing in one space. So I wanted to unpack a little bit what digital pathology is. It's kind of early, so let's walk through it together. Digital pathology, this is a definition that I have taken from the Digital Pathology Association. They call digital pathology a dynamic image-based environment that enables the acquisition, management, and interpretation of pathology information generated from digitized glass slides, often used interchangeably with virtual microscopy. So that's a lot of things all at once, right? So let's unpack that a little bit. This is basically the digitalization of what you're going to see on a glass slide. Kind of exciting, right? So I understand there's probably people from all walks of the profession. We have pathologists, we have doctors, we have technicians, we have students, and everybody in between. I know as a technologist, I hear this question a lot. Cyto what? What do you do? Can you say that one more time, a little slower? So I wanted to unpack a little bit about what is cytogenetics. First, this is a definition from genome.gov. It's kind of lengthy, so I'll read it quickly. Cytogenetics is a branch of genetics that studies the structure of DNA within the cell nucleus. This DNA is condensed during cell division and forms chromosomes. The cytogenetics studies the number and morphology of chromosomes using chromosome banding techniques in classical cytogenetics or hybridization fluorescently labeled probes, molecular cytogenetics or FISH. The number and morphology of chromosomes in a cell of a particular species are always constant. In most cells of the body, with the exception of reproductive cells and others such as the liver, this is a characteristic of each species. In humans, such as the number of chromosomes is 46. Now that's kind of a long way to say about what we do and why we do it. But what I like to tell people is, I look at people's DNA and help figure out what type of cancer they have, what phase they may have, even if they do or do not have, and if their treatment was working. So by looking at their chromosomes, by looking at their DNA, we're helping figure out what stage of disease they're at and what treatment is applicable or if it's working. So you may be wondering, how does this all play into clinical diagnostics? How does this all work? What's the importance of it? I like to think of clinical testing as a book, and I like to start with FISH. I think of FISH in the terms of a book as a sentence on a page. And next, cytogenetics is a page of that book that sentence for FISH lives on. I can use my fancy pointer. And next, we'll move to flow cytometry. I think of flow cytometry as a chapter that holds that page and holds that sentence. And pathology is a section of that book that holds those other 3 components, that holds the chapter, the page, and the sentence that those other testings were on. And then the patient is the whole story. They are all of these things put together and more. And so it kind of gives you a neat perspective on the scope of what we're doing and how it all plays together. So on to the nitty-gritty of cytogenetics. In cytogenetics, we're looking at chromosomes, which are generated during mitosis, the division of somatic cells. So let's review that a little bit. I know it's a little early, but let's review mitosis. Everyone loves a little biology in the morning. So there's several phases of mitosis. We have interphase, prophase, prometaphase, metaphase, anaphase, telophase, and cytokinesis. So let's jump in and unpack each of these a little bit. First, we have interphase, which is a very busy phase. Interphase are where the centrosomes appear on the scene and the chromatin and DNA replicate. Next, we have prophase. This is probably the most exciting one that you're going to see. Prophase, chromosomes consisting of two chromatids are forming along with the mitotic spindles. Chromosome condensation is occurring during this phase, and this next image next door to it is kind of unpacking that a little bit. So during chromosome condensation, the DNA wraps around histones, and I bet you guys have heard the term beads on a string. So first you're going to have your beads on a string formation. And then your DNA is going to loop. It's going to condense around condensing units. Those units are going to stack upon each other. Those units are going to link together. And then lastly, you're going to have a condensed chromosome at the end. So all of this is happening inside of prophase in addition to your mitotic spindle forming. Could you imagine doing all of that all at once? That's a lot going on. Next, we'll move into prophase, where the nuclear envelope is fragmenting and the kinetochores of each chromosome are attaching to the microtubules of the mitotic spindle. Next, we'll move into metaphase. Metaphase is where the chromosomes are aligning along the metaphase plate. It's early, sorry folks. Now this is where we're going to stop for cytogenetics. We're going to stop ourselves at the metaphase stage, and then we're going to dive in and do some other fun things. We're going to see what is needed to visualize these beautiful chromosomes and how we're going to use them. I want to take a break and discuss kind of the relationship and the clinical importance about cytogenetics in fish. So you may be wondering, how does this beautifully packaged DNA really play into the clinical world? How is this clinically significant? How does this actually help people? Well, cytogenetics in fish are important diagnostic tools that are used to identify disease, evaluate disease stage, and evaluate treatment progress. And cytogenetics in fish are two testing types that pair very well together. Cytogenetics in fish, when I think about this and talk about this, I actually attended the UT program with Betty Dunn back when the program was still occurring, and she liked to think about fish as a specific question that gives you a specific answer. And I like to quote her all the time because that is the best way you could think about it, which is why I like to think of fish as a sentence on a page. It's giving you a specific piece of information, where cytogenetics is a genome-wide view of DNA. It is a snapshot of all your DNA all at once. And so, how these apply to someone's diagnosis, with the different resolutions that we have, it's going to give a better picture of what is going on with this person. So you're going to be able to detect amplifications, deletions, unbalanced and balanced translocations, mosaicism, and polyploidy. All of those components are important clinically for providing treatment and diagnostic services to a patient. So let's move on to the fun part, where the magic happens. This is the workflow of how cytogenetics happens at CorePath. First, our specimens are accessioned. If you call into our laboratory, you're going to speak to one of our lovely ladies in the front. You're going to talk to Jennifer, Bianca, or Jessica, they're going to receive your specimen and accession it. Then they're going to hand this off to the laboratory. Here we can see Bo. He is in the process of initiating our suspension cultures. In our laboratory, we do overnight cultures in addition to stimulated cultures. And we'll unpack that a little bit more later, depending on what is needed. Next, we're going to take our cultures after they've been incubated and put them into our Hanabi P2 automated harvester. Now, I don't know if any of you have seen an automated harvester, but these are going to be your best friends. We like to call her Hannah because her name is Hanabi. She is a piece of equipment that's relatively new to our lab, and she is something that greatly increases the efficiency and consistency of our cytogenetics laboratory. It allows consistent harvesting. It allows efficiency for our lab to increase by allowing to free up technologist time to do other things while our harvester is harvesting our specimens. It's a pretty unique and amazing piece of equipment. And this is one of the first stages where you can see automation stepping into our laboratory. Let's see. Next, once Hannah's done, our slides will be dropped on glass slides. And this is Valerie. She's busy dropping slides in our thermotron. Once our slides are dropped, they are baked, and then they will move on to banding. We use Wright stain for our banding, and Bo's busy working away. Bo's kind of our culture and our banding guy. And then we'll move on to the magic step. This is what everyone wanted to see, right? Lastly, we load our slides into our automated slide scanner. This is our ASI scanning system. This has a capacity for 9 slides at a time. So we load our slides, and then we scan them at 10x. Then a technologist will come through and manually select the slides that they want and add oil. And then they will recapture those images that they've selected at 100x. Then, once those images are captured, they are transferred automatically to our analysis software, which is also the package suite from ASI. And you guys may have been using this already. So this is our scanner in action. It's actually, picking stuff up for us. And since there's 2 images there, it's doing the 100x capture. I also wanted to touch base a little bit about old school and new school technology. That's kind of why we're here, right? To kind of see what changes are happening in this field. Now, you may or may not believe this, but when I went through the program and was doing my internships and kind of where the phases of life you guys are at, I learned everything in the old school methodology. I know, right? Some of you are like, there's no way. Yes, way. I actually did my internships and learned everything, and there were not metaphase scanners widely available. We had to do everything manually. That means sitting in a scope, visualizing your slides, being chained to your scope mostly, having analog cameras attached to a digital system, providing kind of grainy images, because when you have a digital camera or a digital software system and an analog camera, the conversion of the files is a little difficult. You had to pass cameras back and forth. It limited the number of karyotypes you could make because it limited the number of images you could take. It sounds like I was working in the Stone Age, right? Nowadays, things are a little different. When I first got hired at CorePath in 2012, I opened the door and found out we had an automated metaphase scanner. I had never seen one. It was more of like this rumored, what, somebody has one? Like, in the industry at the time, they weren't widely used. I didn't know very much about it. We weren't learning about it at that time. So we got introduced to an amazing system that increased not only our ability to do our work, but the quality of our work. So even though you have to manually select your cells for 100x image capture, this greatly increases the image quality of the metaphases that you're taking. So you're using a digital camera, for example, compared to before using an analog camera and a digital software. We get to use high-end digital camera with our digital software, which is making our chromosomes crisp, our banding pop, our metaphase spreads when they're captured, makes you drool a little bit. They're beautiful. That also speeds up your time for actually taking the images. Can you tell I love what I do, right? I'm using words like beautiful and drool. I'm kind of passionate about this just a little bit. Kind of have to be. It doesn't limit the number of images you get to take because you're actually analyzing the images. It doesn't limit your number of chromosomes because you already have your images captured. It actually speeds up the time for analysis. The time that it would take me to, say, sit at a scope and analyze 10 cells versus sitting at my computer analyzing the images is drastically decreased. And all of these things come into play. You have increased speed, you have less eye strain and greater ergonomics. Every lab that I rotated through when I was working on microscopes, every person was having a problem with ergonomics, where you're sitting at a microscope all day, you had eye strain, you had to get your eyes used to it and trained, into using the microscope all day. It's more ergonomic, you have increased speed, our chromosome quality has increased and our karyotype quality has increased. And then this leads into kind of more of our streamlining thing. So if we have increased speed, that's going to increase the review of our cases. And because our image quality has become so much greater, it's so much easier for the pathologists and cytogeneticists and doctors to review our chromosomes. And it's also easier since we have a digital software platform to also communicate and work with other laboratories and work abroad and within the laboratory. It's great. And at the end of the day, this is decreasing our turnaround time, which is increasing the rate at which we can get results to people. Because you wouldn't want to be sitting around waiting for results, would you? This is someone's life. So for example, since we're using digital technology, our turnaround time for a cytogenetics case last year was 4.6 days. That's pretty impressive.
What would you say is the standard without, say, digital systems?
Somewhere between 7 to 10 days on average. Now these are for bone marrows and peripheral bloods. These are not constitutional cases. These are oncological cases, just to clarify. So speaking of digital and digital communication, since we live in a digital age, one of the things that separates CorePath a little bit from other laboratories is how we communicate digitally with people. At CorePath, we have our lab information system, and that is called LabVisor. LabVisor is our LIS system. And this has made a giant leap with our communication. So we have our ASI suite that communicates directly with LabVisor. LabVisor is our cloud-based LIS system that allows us to transfer information directly from one to the other. So for example, when we receive cases and they're accessioned by the lovely ladies in the front, the information is going to automatically transfer from LabVisor to our ASI system, eliminating the need to manually enter in our data. Now when you have 50 cases, 100 cases, 20 cases a day, that eliminates a lot of time, a lot of tech time to enter in and do data transfer, which is a great leap for us. It's amazing. Also, we can upload our karyotypes, our worksheets, and other information directly from our ASI suite to LabVisor. And this allows us to input all of our information, our digital images, our PDFs, any other information directly from one system to another, allowing for a faster review by our pathologists, also increasing our communication with other people. And since this is cloud-based, you can see your results. You're only limited by your internet connection. In addition to that, we also use the Anywhere system provided by ASI. Our Anywhere system is amazing. I love being able to hop onto any place in our laboratory and analyze chromosomes. I'm not limited to one workstation or one microscope or any one place in our laboratory. It's great. So basically, you could analyze chromosomes as long as you have a login anywhere. The other thing that makes LabVisor kind of special is our LabVisor platform allows you to see results from any testing type for that specimen all at once, which is kind of unique for our laboratory. Most of the time you're waiting on results from somewhere else. They're not processed in the same location. In our laboratory, you can look at results for somebody for, say, flow cytometry, cytogenetics, FISH, anatomic pathology, or molecular diagnostics all at once, providing greater patient care for our patients that come in. So it's also decreasing the time that it takes for case review and giving you all of your information all at once for a more accurate patient diagnosis, which is kind of amazing. And working in other systems, there was always kind of a delay. There was always kind of a hiccup. You know, do these results correlate? Does this make sense? We've kind of eliminated that by adapting our workflow to having a digital communication with our LIS and our technical software. So, as promised, I have some interesting case studies to go through. And a little side note I mentioned to Yolanda earlier, I've actually worked on every single one of these cases. It didn't dawn on me till this morning. So let's get to it. Our first case is a 50-year-old female presenting with pancytopenia. Her results for cytogenetics was a translocation 1517 in 7 of her 20 cells, and these results were released in 2 days. And our translocation can be seen right here. Our abnormal 15, our abnormal 17. The FISH results also showed a PML-RARA translocation in 50% of the nuclei analyzed. And this is kind of a highlight of this case study because these results were released the same day. In our laboratory for PML-RARA testing, we actually have a 1-hour hide time for our stat PML-RARA cases. So when this person came in the morning and we received their bone marrow, they had an answer by the afternoon. So they had a positive result. Our flow cytometry also had results of promyelocytic leukemia with a 60% of promyelocytes. This was also released the same day. And here's the scatter plot that correlates with that. And here is our abnormal PML-RARA FISH image. And these are all taken on our ASI system for cytogenetics and for FISH. And our morphology testing also had a result of acute promyelocytic leukemia with a translocation 1517, 70% blast with a 99% cellularity. Those results came out in 2 days. And that's what our histology results look like. So that's pretty impressive. And this is an important, as you guys probably have learned about, an important result because this resulted with this patient having treatment the same evening with all transretinoic acid. So I'm going to ask a question of the audience. Why is that important? Very good. Can everyone hear them? If they don't get treated appropriately, they could bleed out. It affects coagulation. So because of our digital system, because of our automation in our laboratory and the probes that we're using, we were able to give life-saving results to someone within the same day and basically save someone's life. Let's move on to case study number 2. We have a 45-year-old female presenting with a diagnosis of CML. Cytogenetics was able to release a result of a translocation 922 in all 20 cells analyzed. And these results were released in 4 days. Here is our translocation. Here's our abnormal 9. Here's our abnormal 22. Our FISH showed a rearrangement of the BCR-ABL probe in 99% of the cells analyzed. And a deletion of the ASS location was not detected. And those results were released within the same day as well. And I like to show BCR-ABL cases because these are a great example of one of the reasons we do what we do. The treatment for a case like this and what this patient received was a treatment of Gleevec. Gleevec is a specific treatment for a specific genetic abnormality. And you guys have all heard about personalized medicine. This is a classical example of personalized medicine. Let's move on to case study number 3. Let's look at some more chromosomes. Let's spice things up. Let's see, we have a 32-year-old female presenting with AML. Oh, this one's so much fun. I'm gonna step over here. We have, for cytogenetics, results within 4 days. We have a translocation 8-10-21. So, let's backtrack a little bit. Fish, we probed for an ETO AML, and it showed an abnormality in about half of the cells, 56%, right? So we have a signal pattern of 1 fusion, 2 green, 2 red. Okay, and that we released that in about 3 days. Now, chromosomes, we figured out that the region of the 8 was going to the 10, moving to the 21, and then moving back to the 8. If that doesn't get you excited this morning, I don't know what will. So this is a great example of a case that shows the relationship of cytogenetics and fish and how they can correlate together. So AML-ETO, the probe we were using, asked a specific question and gave you a specific answer. It told us, yes, the AML-ETO region was abnormal. However, when you pair it with cytogenetics, since we're looking at the entire genome all at once, we were able to say, yes, the AML and ETO regions that normally live on the 8 and the 21 are abnormal, but we can tell you how they're abnormal and where they went. So we were able to figure out that your regions were moving from the 8 to the 10 to the 21 and back to the 8 with an atypical result. So that's pretty exciting. Let's move on to case study number 4. Okay, we have a 60-year-old male with a diagnosis of a JAK2 positive myeloid neoplasm. Now this case only had cytogenetics, and the results were released in about 4 days. And here's what we found. We found a translocation 7-1. And now we call this a derivative 7, resulting from a translocation 1-7. And this is a known and a rare abnormality seen in AML that is preceded by myelodysplasia. Now, in addition to this derivative chromosome here, you have trisomy 9. You have 3 copies of chromosome 9. Now, this is already known rare abnormality for AML, but it's also known that clinically speaking, and this is rare on top of just having this derivative chromosome, this trisomy 9 indicates a secondary change. And unfortunately, that is a poor prognosis for this patient. But we were able to see clear results and give a prompt diagnosis. So could you imagine trying to figure this out if your chromosomes weren't clear? That'd be really difficult, right? And you wouldn't want to provide poor chromosomes or struggle with trying to figure out what's going on, especially with a rare abnormality or something that is clinically significant. So that's pretty awesome. Let's move on to case study number 5. We have a 28-year-old female presenting with BALL that is BCR-ABL negative. Within 2 days, Cytogenetics and Fish both released their results, and there was an abnormal pattern for the E2A region by Fish. The E2A region lives on 19P. There was an abnormal E2A region in 88% of the nuclei analyzed. So again, we have a relationship between cytogenetics and Fish. Now, we do know that E2A is abnormal, specific question, specific answer. Now, cytogenetics also showed some interesting abnormalities. We have a triplication of the 1Q on chromosome 1. We have a translocation between the 3P and 12P, in addition to a derivative 19 resulting from a translocation 1-19. So we knew that E2A was abnormal, but we also know how it's abnormal now. We know that it's abnormal because it was involved in a translocation between the 1Q and the 19P, disrupting that region. This is another great example of how the testing types go together and to provide a more clear and accurate diagnosis for this patient. Case study number 6. we have an 18-year-old female presenting with a diagnosis of CML. Let's see, for cytogenetics, we had results released in 4 days. Let's start with fish first. I got ahead of myself, sorry. So fish showed a rearrangement of the BCR-ABL probe in 99% of the cells analyzed. However, fish also showed 2 cell lines going on for their BCR-ABL. So, as you can see here by our fish ISCN, we have an atypical rearrangement in addition to a normal BCR-ABL pattern, and those results were released in 2 days. Cytogenetics were able to provide some clarity onto what the fish was seeing. They saw an extra abnormal pattern in addition to other things going on. So fish was able to detect the abnormality. They are still ill. We have a translocation 922, which was detected. We also have an additional Philadelphia chromosome, which is explaining the fish signal pattern that we're seeing. In addition to that, we have a trisomy 1, and here's the kicker. There was a low level of isochromosome 17q. Now, with these 2 testing types paired together, we were able to provide a clearer diagnosis for this patient. And the ISO 17q paired along with these other results, especially the translocation 922, this is indicative of a secondary change. Now, in these results are kind of important. You have a secondary change, and this is indicative of impending blast crisis. So we were able to provide someone with results that potentially change their life. They have an impending blast crisis that's going to affect their treatment plan and their outlook. So we were able to provide better stories for this patient's life. And lastly, I have one more. I know we all like looking at chromosomes and fish early in the morning. I have an 87-year-old male with a diagnosis of unspecified B-cell lymphoma. Cytogenetics released results in 4 days with the results of a -Y and trisomy 12. Pretty straightforward, right? And for cytogenetics, due to the indication of the B-cell lymphoma, we stimulated our culture, one of our cultures, with CpG-IL2. If the diagnosis indicates, we will stimulate using CpG-IL2 to ensure that we are looking at the proper cells. So our stimulated culture showed the trisomy 12, where our unstimulated did not. And I'll touch base on that in a second. So our NHL panel for fish, our B-cell NLH panel, was all normal. All of these probes, our MYC, our BCL6, our MALT1, our IGH, our IGH-CCND1, and our IGH-BCL2 were all normal with results in a day. Our flow cytometry indicated that it was involved by B-cell lymphoma with a 30% kappa-restricted B cells with a 4-day turnaround time. And these are the scatter plots for this patient. And then morphology also showed 70% B-cell lymphoma, and the iron stores were decreased with a 4-day turnaround time. The CpG-IL2 stimulation was able to provide further and finer detail into the diagnosis of this patient. The trisomy 12 is very important for a lymphoma case, providing more information for the clinician and for diagnostics purposes. So because of this stimulation, we were able to detect something that otherwise would not have been detected, providing for further clarity. So to wrap things up, I wanted to touch base on why we do what we do. Why did we perform clinical testing? And I want to introduce you to Miss Rosie. Miss Rosie is the reason why we do things. We cared for her samples, and actually cared for her samples several times over, and actually over the last couple of years. Our diagnosis led to her eventual treatment, diagnosis, and the end result. Unfortunately, Miss Rosie passed away last year. That's kind of difficult. I really don't want to cry, so I'm going to read a little bit. We all worked really hard. I worked on her, all of our sections worked on her. her results were not very good. After our diagnosis and our timely diagnosis, she was able to live an additional 2 years afterwards. And she was really able to live. She is quote unquote a self-proclaimed spicy lady. And she really was spicy. She was great. And here's what she did in those 2 years. Well, here's a little background on Miss Rosie actually. She lost her husband at a relatively young age, and she had to become a single parent to 4 kids. She went back to school and was working full-time in a time where most women that wouldn't have happened. She supported her children, she worked her entire life, and once she had her diagnosis, she traveled, she took classes she wanted to get into, and she got into everything. Oh my goodness, did she get into everything. She also dabbled in online dating. And that comes into this story. She met a man 13 years younger than her, and she self-proclaimed robbed the cradle. She's a spicy lady, right? She was great. He was there for her when she was ill, taking her to her appointments, always for her treatments, for anything. She was always at the clinics we were at. We got to create a great relationship with him as well. She would always say that he was such a great cook, and he pampered her and took care of her on hand and foot. And she remained spicy up until the end, very good-natured, and she was so appreciative that we were able to give her an answer of why she didn't feel very well. She came in and, she just didn't know what was going on, why she didn't feel so good. And even though she only had 2 years after her initial diagnosis, she appreciated the fact that we were able to give her a full 2 years to live a great life. And that's why we do what we do. We work for people like Miss Rosie. Okay, lastly. Anyway, I'd like to give a couple of thanks and introduce you to our Cytofish team. Right back there. We have Valerie, Maria, Nupur, Maria, Robbie, Bo, Cirque, and Belinda. And then this is the rest of our fabulous CorePath crew, all of our other departments at our groundbreaking ceremony. And without them, we couldn't do what we do, and they're great. And lastly, my last thank you for a few people. Our Cytofish team at CorePath, my CorePath crew, all of them, ASI for inviting me to speak, and you lovely people for listening to me talk for about 45 minutes. And lastly, happy Lab Week. If you guys didn't know already, it's National Lab Week. So enjoy, and thank you for having me today. And that's all I have for you. Time for questions.
Are you planning to open up a lab here in Houston?
That I do not know. But if you were to grab one of my cards and shoot me an email, I could give you further information on that. So at CorePath, we actually we perform bone marrow clinics where our pathologists go on location and perform the bone marrow biopsy, which is how we're able to kind of meet our patients.
So CBGIL2?
Mm-hmm.
Is it overnight?
That is a
72 hours.
72-hour culture.
And how many microliters do you use? How much do you put in?
We use 100 microliters of each CPG and IL-2, so a total of 200 microliters.
So you fix it?
Yeah. Mm-hmm. You're welcome.
There is a program to work on the online.
Mm-hmm.
So is there any cytogenetics who working only online, living remote?
Not at this time, but that software provides the potential for that. So if you worked for a laboratory that had that, there is the potential for it to grow in that area. However, at this point, we do not. But who knows what the future will hold. So.
Is there a question on Genesis Anywhere?
Yes.
What was the question? What's the question then?
If the anywhere you could work remotely. It has the potential to, but at our lab, we work on site.
The Genesis Anywhere software is designed around the concept of being able to remote in from a remote area, do full analysis
capabilities, not just review capabilities, but full analysis capabilities from it. So it can be used as a remote workstation. What's nice about it is, as they're using it in their lab, is it gives them the ability that they don't have to buy a whole bunch of workstations. If they have 10 techs, but only 5 of them are working at one time, why buy 10 systems?
Yeah.
You're looking at the cost difference there. I can then have this license, and those licenses are like floating licenses. They can use it on their personal computer. So a doctor in his office that's doing review can get onto that system and do review. The person who's logging in, is doing the prep work to get the samples into the system, into the LIS, they can work and look at our system at the same time. They don't have to have their own personal system. So that way, you use the systems when they're needed at what part of the lab you want to, inside the lab or outside of the lab.
So for example, a great scenario was we had a really busy Friday a couple weeks ago, and all of our stations were full. We were trying to get our specimens out. I was able to sit at my QA desk across the lab, do complete analysis, upload it to our LIS, and create an additional virtual workstation. So you actually had, instead of being limited by your number of workstations that we have 4, I was able to be a 5th. I could be the 5th man that day and perform analysis.
With using the cloud, would there be any security concerns with things being in the cloud?
Like your
Unfathomable.
like PHI and things like that. Our LIS is completely secure and HIPAA compliant, and so is the ASI system.
The way the system works is this: it does have a security monitor within it, so the product itself is HIPAA compliant. The way that it works is this: is that you first have to have the capability of being able to enter into that laboratory's IT area. So when you log in through the software, you have to have that security clearance just to get into, say, MD Anderson. So if you have that remote capability of getting into MD Anderson, then at that point you have the security of the software has a second security that allows who can get into it from that point. So even though you can get into CorePath, you can get into MD Anderson, then when you want to use our software, you have to also have security clearance into the software. Once you're into that, then you're able to work on patients. There is ways of setting it up so that, because it is a remote software, we have it designed so that if I have outside doctors, I can set it up so they see only their patients. So there's even security set up for that as well.
Okay, if that's all we have, that's all I have for you folks. Well, thank you so much.